Okay, guys, we're doing a little talk about exam packet 3, and here we're going to recall some things of trigonometry. So don't forget your ratios, sine, cosine, and tangent, SOHCAHTOA, okay? And so you take a look at something, a couple of these, find the sine or cosine of angle B. So the sine of angle B is the opposite of the hypotenuse, okay? The opposite of the hypotenuse, which is 15 over 39. Okay, so that's it. And really, that's all you have to do for that. Just set it up, okay? Um, we then have some problems that we have to look at here, okay? So let's take a look at something like, something like find number 4, okay? So it says find angle A. So it says that CB is 10, AB is 19, and so we're after angle A. We're just going to put an X in there. So relative to the angle, we have the opposite length and the hypotenuse. So that sounds like the sine. So we set it up. The sine of X is equal to the opposite over hypotenuse, which is 10 over 19, which means that now we're actually solving for X. So angle X is equal to the sine inverse of 1019. And of course, you got to go to your calculator with that. And you're going to find a bunch of problems similar like that, okay, that you're going to have to do. Okay, you have here, okay, your angles of elevation. You got to remember they're always made relative to the horizon. Okay, so number 7, a person is standing on the edge of a cliff and his friend is down below. The angle of elevation is the angle of elevation QSP. QSP is in fact the angle of elevation. Okay? So that answers that. Now, the angle of depression, okay, would be the angle relative to the horizon, which would be this angle in here. All right, from that person's perspective. Okay, here you are. Okay, when a ladder reaches a window 50 feet high, so that means, okay, here you go. That AB length is 50 feet. All right, and it makes a 65-degree angle with the ground. That means this angle X is 65. Okay, so here you go. Looking at it this way, here's 65. Okay. What is the length of the ladder? So that's X. So that is going to, relative to the angle here, you got the opposite and you got the hypotenuse. So that's a sine. So the sine of 65, which you'll consult your calculator for, is equal to the opposite, which is 50 over X. Okay? So the tangent is touching a circle at a single point, which I missed. The secant is touching a circle at 2 points. Okay. Uh, okay. So now we start measuring some angles and central angles. Okay. And then some concepts to recall here. You actually had these in the previous worksheet, but it seems like you need some more practice on them. So we'll take a look at some of them right here. Okay. Um, so it says in this circle, BCP, that's the angle BCP is 52, and angle ACR is 93. So they're both central angles, okay? And so let's just find some of these things, okay? I think you can find most of those other angles. Let's find those arcs. AQ, okay? AQ is this arc. But that arc, we don't have an angle. Well, yes, we do. We have the vertical angle here, 52. So AQ is 52 degrees of arc. Okay, and then you have what? ABR. ABR entire. So that's a long sweep. That's going all the way from, that's a major arc, okay? That's a major arc. That's this whole sweep along here, which is, okay, everything but what is formed by that 93-degree central angle. So this is, this is going to be 360 minus that 93-degree angle, okay? Let's move on. Okay, we have some problems here that look like they might be interesting. Okay, we've got that arc BE is 84. Find BAE, that's angle BAE, so that's got a BAE is equal to 84. And BCE, okay, well BCE is the inscribed angle opening up to that arc. So that's half of that arc of 40, so it makes it 42. Okay, so that's why we have, okay, here the angle is central angle, and it's opening up to the arc, which is the same measure. Okay, so, and then here we have the inscribed angle, which means it's opening up to arc, which is twice its measure. So since this is 60, this arc is 120, and then this angle here is going to be 120. Okay, we got to remember those things. Okay, let's take a look. All right, this problem looks like fun. Okay, in this diagram, what is the sum of the measures of 1, 2, 3, 4, and 5? Well, look. Okay, this angle intercepts one portion of the arc. Angle 2 intercepts this portion of the arc. Angle 3 is not even asked for. Angle 5 intercepts, okay, this portion of the arc. Hey, if you look at it, they're going to equal 180 degrees because they're going to equal all those arcs up together. So it's just a logical puzzle. Here, this is the interior angle. And that means that angle E, which is this angle here, is 1/2 the sum of the two arcs. That's the sum of arc AB plus arc CD, which are given to you. So just plug the numbers in and charge away. Okay, this here is an exterior angle. All right, I'm going to put a point out here called P. So the exterior angle, the formula, in this case we're calling it X, is 1/2 the difference of the furthest arc, which is a major arc, which is going to be APB, minus the remainder of the circle, effectively, okay, which is arc AB. So it's the 1/2 the difference of the furthest arc and the closest arc, okay? That's exactly what is going to apply here. This C is 1/2 the difference of AE and DB. Let's plug the numbers in, okay? If you want to find, and the radius, okay, so here we're trying to find the measure of angle ABC is 50, okay? And these are equal segments. The radius is the circle. So they want to find the arc length. So the arc length, AB, arc length, okay, is equal to, okay, it's some fractional part of the entire circumference. Okay, sorry if this is getting a little long, but so then times, that's some fractional part of the entire circumference is some fractional part of 2 pi r. Okay, that's the arc length. That's the arc length. They tell you this angle is 50, so that makes that arc 100, since that's twice the inscribed angle. The remainder of the circle is 360 minus 100 is 260. and that's going to be divided evenly on these two arcs. So 260 divided evenly is 130. 130. So this is going to be 130 over 360 times 2 pi r, and they give you r, so just crunch those numbers out, okay? Then we have some figures here, like, okay, like what is this shaded region? Well, if that's a rectangle, maybe even a square is a square actually, minus, okay, the semicircle, okay? So that shouldn't be a big deal. Okay, these are what we call, let's just come back up here, sorry about that. Okay, here, okay, this is some, we want to find what fractional part of that is this, okay? So, we want to say it's some fractional part of the entire pi r squared, the entire area of the circle. What fractional part, okay, is determined by this angle? Well, it's probably easier to figure out the angle in here, okay, but that's our formula, okay? That's the what we call the sector. The sector is a fractional part of the entire area of the circle. Okay. Oh well, they actually tell you that sector. They say it's equal to 39 over 8 pi. Okay. So then basically you should be able to resolve that. Okay. Because they give you the radius. They give you so you just solve that for. Now, mindful what you're finding is this arc, this angle, and you want the one that's there, the smaller of those, okay? If you remember this, this is going to be, okay, this whole area, all right, which is the sector, okay, which is 90 over 360 times pi r squared minus, so we come along here and say minus what? Minus this triangular region, okay, which is going to be, 1/2 of, that's a 90-degree arc, so it's really just the length times width, which are the same. And it tells you that the radius is 8, so it's 1/2 of 8 times 8, so you can figure that out. This one is just the difference of two circles, the area there, and that does it, okay? So, sorry I got a little lengthy, but I think it should be very helpful, okay? There you have it.